Section 6.7, Applied Problems. Or more realistically, let's see how we can put trig to work to figure some things out. So all the problems in this section, for the most part, are going to be dealing with right triangles, where we're going to come up with a right triangle. And so everybody is using the same notation. We're going to introduce some common notation so that when we're referring to a triangle, and I'm using some language, or anybody's using some language, then we're always referring to the same thing and there's not any question. So the vertices, or the corners of our triangles, we're always going to use just our capital letters, A, B, C. Typically we're going to use A, B, and C. The angles at those vertices, we're going to use the lowercase Greek letters. So those four that are listed there are alpha, beta, gamma, and delta. And again, we're typically going to be using the first three, alpha, beta, and gamma. And then the sides of our triangles, those sides across from those angles or those vertices, are also going to be our letters, but now we're going to use lowercase letters. So sides are A, B, and C. We're going to be solving triangles. So to solve a triangle, basically we need to find all the unknown parts of that triangle. And that basically means that we are determining all the side lengths and we're determining all the angle measures. Now, whenever possible, you should always use the relationships that are given rather than any information you calculated. And that's for a couple reasons. If you make a mistake calculating a side and then you go ahead and use that side to calculate something else, then that second thing that you're calculating is going to be wrong because of your first mistake. So whenever possible, use only the given information. Next, we have an angle of elevation or an angle of depression, and you might remember this from geometry. The angle of elevation or the angle of depression is the angle between the horizontal and your line of sight to that object. So here's my horizontal from my line of sight. Going up to the airplane, this would be an angle of elevation, and then since I'm looking down to the dog, that would be my angle of depression. And now let's move on to directions or bearings. This is used in navigation. So a direction or bearing is going to be the acute angle made with the north-south line. So just to have a mini refresher on the compass rose, if we have a normal compass rose, remember this is north and that's south, this is east, and that would be west. So if I were to have, let's say up here, let's say this is point Q, and let's say this is a 30-degree angle because this is my north-south road. We would say that Q, now we're going to think about, if you were to think about making a triangle, first of all, from here you would have to go north. So you're going to go north, and then you would go 30 degrees to the east. So the bearing for that one would be north 30 degrees east. Similarly, let's say I have an angle out here. And again, it's off of the north-south line. So let's say that's a 70-degree angle. If this is my Q, again, to get out to that point, the first thing I have to do, Q is, first I would go north, and then I'm going to go 70 degrees, but now I'm going west. So this would be a bearing of north 70 degrees west. Continuing down this way. Again, we need to know what the angle is off of the north-south. So if this was a 45-degree angle, we would say that Q, this is Q out here, is to get from here out to Q, the first thing I have to do is go down. So we're going south, but then I'm going 45 degrees and I'm going to the west. So that would be a bearing of south 45 west, 45 degrees west. And then finally, you can probably guess what this bearing is going to be. If this is 80 degrees off of my north-south line, that's my Q. I would say that Q is, firstly, I'm going south, then I have to go 80 degrees, and I'm going to the east. So my bearing would be south 80 degrees east. And so keep in mind, that's why when we say if we're just going due north, we're not going east or west at all, it will be just due north or due east. Now let's do 5 problems and we'll put some of this information to work. So the first thing we have to do is solve ABC, triangle ABC. You can see that we're only given 3 parts of it, which means we have 3 parts that we have to find. So the first thing I'd like you to do is pause the video and draw a triangle and label your triangle with the information given. And then also write down, kind of in a column format, I'll show you what I mean, the information given. So first of all, let's draw a triangle. Obviously, gamma is my right angle there, which means side C is across from it. I wasn't given that. Now my angle alpha and beta are somewhat arbitrary. We don't have to draw triangles to scale, so I'm going to put my 34-degree angle there, which means side A is across from that, which means this has to be side B, which is 10.5, and angle beta is going to be across from that. Now I've got my triangle drawn, and I've got my sides and angles that I know listed. How can I most easily find angle beta? Do you remember from geometry that the angles of a triangle have to add up to 180 degrees? Well, since I've already gotten 90, that means that my alpha and beta have to add up to 90 degrees. So I can find beta by taking 90 minus my 34-degree angle, and I get that my beta is 56 degrees. Now I need to find A and C, sides A and side C. So if we notice, side C is the hypotenuse, and I have this angle 34 degrees, and side B is the adjacent side. So if I recall, I can write that the cosine of 34 degrees is going to be the adjacent side, so 10.5, over my hypotenuse. And so now I just need to solve that equation for C. Multiplying both sides by C, I get the C times the cosine of 34 degrees equals 10.5. And then I'm going to divide by 34 degrees. So 10.5 divided by the cosine of 34 degrees. I'd like you to go ahead and pause and put that into your calculator. Make sure that your calculator is in degree mode. And you should get that C is 12.66. So over here I can write we can just go 12.7. And now we notice that we have side A. Again, I don't want you to use the Pythagorean theorem, because if we would have made a mistake on our side C, then that means we're going to get side A wrong. So now if we look at angle 34, I have the opposite side and the adjacent side. So now I can use the tangent of 34 degrees is the opposite over adjacent. And again, multiplying both sides by 10.5, and then taking 10.5 times the tangent of 34 degrees, I can find that A is 7.08. So now I've found all the missing sides of my triangle. I have solved that triangle. I would challenge you to pause the video and attempt to solve problem 2 on your own. The first thing we need to do is draw a triangle. So I drew my right triangle. There's my gamma, which means across from that is side C. I'm not given it. I'm given side B, which means across from that is angle beta. And I'm given side A of 12.3, so across from that is my alpha. Now I am given two sides of my triangle, so the easiest way to find side C is going to be to use the Pythagorean theorem. So go ahead and pause and do that. In doing the Pythagorean theorem, we get that our side C is 33.91. Oh, I forgot to draw my little chart. We need to do that. So now I can fill in that my side C is 33.91. And now I need to find angle beta and angle alpha. Well, it doesn't matter which side I find first. Either way, I'm not given the hypotenuse, so I'm given an opposite and an adjacent. So I'm going to use that to find my tangent of alpha, which only means it matters which one is on top. So alpha's here, so the opposite is going to be 12.3 over 31.6. Remember, to undo tangent, I'm going to take the inverse tangent of both sides. So the tangent and the inverse tangent undo each other. So I have the inverse tangent of 12.3 over 31.6. I would encourage you to leave that as that decimal before you get ready to put that into your calculator. And now again, I would encourage you to pause the video, put that into your calculator, and make sure that you get the right value. When you plug this in, you should get that alpha is 21.3 degrees. Now we could use the tangent again doing the tangent of beta is 31.6 over 12.3. We can also, though I told you not to do that, we could also take 90 minus 21.3 and come up with the sum of triangle is 180 degrees, and so beta is 68.7 degrees. Problem number 3. From a point on level ground 130 feet away from the base of a tower, the angle of elevation to the top of the tower is 57 degrees 20 minutes. Approximate the height of the tower. Again, first thing we need to do is draw a triangle. With my triangle labeled, I need to find the height of my tower. So again, I don't really care how far it is from the ground to the top of the tower. I'm given or need to find using the tangent. So I'm going to have the tangent of 57 degrees 20 minutes equals the opposite, my tower, over the adjacent, which is my 135 feet. Again, multiplying both sides by 135, we get that t is 135 times the tangent of 57 degrees 20 minutes. Put that into your handy-dandy calculator, and we get that tower is 210.55 feet tall. If you don't know how to put those degrees and minutes in your calculator, you can either change the minutes into degrees and use a decimal, or if you want to come to class, I will show you how to put the degrees and minutes using your graphing calculator. Problem 4. From the top of a building that overlooks an ocean, an observer watches a boat sailing directly towards the building. If the observer is 100 feet above sea level, and if the angle of depression of the boat changes from 25 to 40 degrees during the period of observation, approximate the distance the boat travels. So we have somebody that is 100 feet up. And when they first spot the boat, it's way out here, and it forms an angle of 25 degrees. And then they watch it for a little while, and as it comes in, it then forms an angle of 40 degrees. And we want to know, what is that distance? How far did the boat travel? So if we call this boat, or this distance D, and we call that distance K, we actually have two right triangles. And so if we can manage to find, we need to find D. So if we notice, if we can find the total distance K plus D, and then we can subtract the distance of K, we will have the distance D. So how can we do that? Well, let's start off looking at this smaller triangle, the 40-degree angle. So again, I have the tangent of 40 degrees, because I have the opposite and the adjacent, equals 100 over K. Multiplying both sides by K and then dividing by the tangent of 40, I get that K equals 100 divided by the tangent of 40 degrees. And then putting that into your handy-dandy calculator, you get that K is 119.18 feet. Now let's look at this bigger triangle. And I'm going to do a similar thing, except now I have the tangent of 25 degrees is 100 over K plus D. When I do the same thing, I get that K plus D equals 100 divided by the tangent of 25 degrees. Plugging that into my handy-dandy calculator, K plus D equals 214.45 feet. So now again, I'm going to use K plus D, 214.45, minus K, 119.18, and I see that I get 95.27. So in the time that the person watched the boat traveled 95.27 feet. This last problem is a little bit involved. I would really challenge you to do this on your own. Otherwise, you'll have to tune in to the next video that covers just that problem.